so let's just start out by filling out our formulas for our prisms today. Here's our prism. I would like you to write for surface area 2 capital B plus capital P H, and for volume, capital B times lowercase h. Now the reason that I specified capital is because a capital B stands for something. It's not just base. When I ask you what does B stand for, you're going to say area of the base shape. You might need an area formula to calculate capital B. Same thing, capital P is the perimeter of the base shape, not just perimeter, perimeter of the base shape. Now H is the height of the actual prism. So we're going to do a little coloring just to let that sink in. Grab a colored pencil, and I would like you to color in the 2 bases on a prism. Every prism will have 2 bases, and they will be congruent, and they will be parallel. That's just the definition of a prism, is that we're going to have 2 congruent shapes that are also parallel, and we're going to color those bases in a color of your choice. How many bases are there? There are 2 bases. And so this B right here, it kind of makes sense that there would be a 2 in front of it. If we were going to find the area of the entire thing, why don't you color code this too? If we were going to find the area of this entire 3D shape, the 2 bases, makes sense, would be our 2 colored pieces. So what about this pH? The pH is a calculation that finds the area of all of those rectangles that surround. So in this picture, there would be 6 rectangles, right, around the sides. We actually have a special name for the shapes around the sides. Those are called the lateral sides, or the lateral faces. These rectangles, and so you probably want to label that are the lateral faces. So the capital B is the area of the base shape. The capital P is the perimeter of one of the base shapes. And the height is actually the height of the prism from base to base. That's a nice way to remember what height means. It's the distance between the 2 bases. Same thing on the volume. Will you color code that capital B? Because we're going to take the area of the base shape and multiply by height. Now as we do some examples, I'll tell you why these formulas make sense. Alright, so first I wanted to explain why the surface area formula works. I think the 2B is kind of obvious, like B stands for the area of the base shape, and we should have 2 of those included. But the pH, that lateral area, should include all of these rectangles that are wrapped around, right? Well, if you use these numbers, the height of each of those rectangles is the same as the height of the prism. And the width of each of those rectangles, we could do 3 times 4, we could do the 3 times 5, we could do the 3 times 3. But actually, a quicker way to do that would be to take the 3 times the 4 plus 5 plus 3. If you're familiar with factoring out a 3, you'll know that these are the same. So that's just taking the height of the prism times, do you see what this is? It's the perimeter of one of those base triangles. So the perimeter of the base shape and the height is basically just taking a base times a height, a base times a height, and a base times a height, but just doing it all in one step. So that's the reason that that formula makes sense. I also have a way to explain why area of the base shape times the height would make sense. So if this were a 4 by 3 by the back edge is 5 triangle base, well, does it sort of make sense, like if you look at these cubes, I'm going to pretend they're cubes of water. If we did 1/2 base times height for like that bottom triangle, the area of that base shape, what does that equal? 6. That actually is how many cubes of water fit just on that base layer. So we could think of that as 6 cubes on the base layer, and then you just have to think, okay, how many of those do I want to stack up? I've got this layer, I've got another layer, and I've got another layer, until you fill up that total height, right? So you can actually think of that H as standing for the number of layers. So I just like to realize where these formulas come from. Helps me memorize them a little better too, which is coming up. This is going to confuse a lot of people. Do you know what the base shape is on this prism? This is probably the most commonly misunderstood thing. What shape is the base? And a lot of you might be looking at this and thinking, oh, well, it looks like it would be that rectangle that's on the table. Or maybe the base is this sort of square on the top. But remember that in a prism you have to have 2 identical base shapes, and they have to be parallel to each other. So it couldn't be this face and this face. Even though those look congruent, they're not parallel. They would eventually intersect. The weird part about this is that this is actually a trapezoidal prism. It just happens to be tipped over on its front or back, but those 2 base shapes are the trapezoids that are on the front and the back of this shape, which is kind of crazy because then, you know, if it stood back up, its height is right here. Imagine if you were laying on the floor and your head was here and your feet were here. Your height would still be considered the distance from one base to the other, from your feet to your head. And so that's how we're going to think of the height of a prism, is according to how far apart its head and feet are. So here's some measurements actually put on there. Let's do this one together. I really like to structure these all sort of the same. So the first thing I find when I'm doing one of these problems is I find capital B. Will you guys all say, just out loud right now, what does capital B stand for? If I were there, I would be listening to hear, did you say base? Because that's not what I want to hear. I want you to say, capital B stands for area of the base shape. I'm even going to write it this time. Area of, and in this case, area of the trapezoid. The front trapezoid, the back trapezoid, both of them will be the same. The reason that's so important is because we have this whole formula that we have to go through. So now you see why I was so set on reviewing those formulas. So let's take a look at one of those trapezoids and let's calculate the area of that base shape. What do we have? We have 1/2 times 9.8 plus 3.8 times, now this h is the height of the trapezoid, obviously, because we're finding the area of the trapezoid. And the height of the trapezoid is also the distance between its base sides, right? So that 2.3 is the height of the trapezoid. Let me type that in quick. I'm going to make sure I put parentheses around the 9.8. If you want to try typing this in, not a bad idea. I am getting, for the area of the base shape, 15.64. And since that is an area, I'm going to say that that's measured in square centimeters. I'm just going to save that now. The next thing I like to find is capital P. Will you say out loud, what does capital P stand for? Perimeter of the base shape. Excellent. Perimeter, don't just say perimeter. Perimeter of that base shape. That's important because if you just say perimeter, who knows? Are we going to add up every number in the picture? No, we're going to add up just the perimeter of one of those trapezoids. And P just means like the perimeter of one of the trapezoids. So I'm going to take the 3.8 plus the 3.8. Did you notice there were 3.8s on this trapezoid? And then that 9.8 on the bottom. So let me type that in. And I'm getting 21.2. And that's just a distance around the trapezoid, so that's measured in centimeters. I just like to write out each of those because then when I go back to do my actual surface area, I have all the numbers I need. So let's do this. We need 2 area of the base shapes. So I've got the 15.64, and I've got the perimeter of the base shape, which was 21.2. All right, let's talk H. In this formula, the height of the prism, as if it were standing up on its base shape, it's the distance between the 2 base shapes. And so that 3 is the height of the prism. The 2.3 was the height of the trapezoid. The 3 is the height of the prism. I know that's a little confusing. We'll get used to it. Let me type that in for you. So the 2 base shapes add up to 31.28, and then I'll add on that lateral area, and I'm getting a total surface area of 94.88 surface area square centimeters. That means, like, if I had little stickers that were 1 centimeter by 1 centimeter, it would take me almost 95 of them to cover this whole shape. Let's fill it up with some water. So volume is where we're filling it up with water. Area of the base shape was, we calculated that as 15.64. That means that it would take about 15 cubes of water, to fill this, just that bottom layer, to cover that trapezoid in cubes. And then I would need to keep stacking layers of water. And how tall do I stack them? Remember, the height of the prism would be from base to base. The water sunk down to this bottom, and then I'd be able to pile 3 layers of cubes in there. 15.64 times 3, 46.92, and that's cubes of water to fill that entire solid. So you're looking for a little extra challenge. We've got this prism, which is a pentagonal prism. I can tell because I see that pentagon on the top, I see the rectangles around the side, and I can imagine that there's another pentagon on the bottom. It tells me that each of these side lengths is 3 inches. And this S equals 3, in this case, the height right here is also 3. Basically, every edge of this solid is 3 inches. Fantastic. So let's try to get behind this system of mine. It's really nice. If we can find B and P, it's just going to make everything so easy. What does B stand for? Area of the base shape. And in this case, it's the area of a pentagon. Do you know that formula? Turn to somebody next to you and tell them the formula to find the area of a pentagon. Did you say it? 1/2 Apothem times perimeter. Beautiful. That one's going to be the tougher one. So let's do P first. What does P stand for? Perimeter of the base shape. And so the perimeter of the pentagon would be 3 plus 3 plus 3 plus 3 plus 3. So each of those pentagons has a total perimeter, is it 15? In this case, we're in inches. Great. Let's work on that area. A little tougher, only because nobody told me what the apothem is, right? The apothem is from the center to the middle of one of these edges. By the way, because it has to go to the middle, I know that this is going to be a 1.5 and a 1.5. That could be useful. I'm going to label this with an A. You guys did one of these recently where if you draw in this little segment, you notice that there's a right triangle involved. So that can sometimes be helpful, but really only if we either know how long the hypotenuse is, or if we knew how big one of these angles were, then we could do some SOHCAHTOA or something. I claim that we can actually figure out, this angle is probably the easiest to figure out. You know how this is 360 all the way around? Okay, well if these each split nice and evenly, right? We could split that into 5 pieces. So we could take that 360 degrees, split into 5 pieces. 360 divided by 5, 72 degrees. That means each of these is a 72 degree angle. I don't know if you caught this, but that would be this entire angle is 72. So we'd actually have to cut that in half one more time. That's a 36 degree angle up in there. Another way you could do this, just to remind you, remember the old n minus 2 times 180? That would help us find the measure of one of these angles. If we did 5 minus 2 times 180, spoiler alert, I think that makes 108 degrees each. If you split that in half, what would that be, 54? So each of these little corner guys would be 54. You don't have to do both of those because notice that the 90 and the 36 and the 54, they all add up to 180 total in that triangle. So either or. Do you like the 360 divided by or the n minus 2 times 180? Whichever one, it doesn't matter. All right. We still haven't found the apothem. I know, this is going on forever. Let's find out how long this apothem is. So if I'm looking at the 36 degree angle, did you notice that I know how big the opposite side is? And I have no idea about this hypotenuse, but I do know that the adjacent side is the apothem. Do you remember? So, ka, or toa relates opposite and adjacent. Did you say toa? So here's this little side calculation I'm doing now. I'm saying tangent of 36 degrees equals opposite over adjacent. I like the old cross multiply method, so I'm going to take the tan 36 times A, oops, and then the 1.5 times 1. To solve for A, I'm just going to divide that tan 36. Now might be a good time to test those calculators. If they're still in degree mode, then we should be able to just type in 1.5 divided by tangent of 36 degrees. And I'm getting an apothem of about 2.06. Now honestly, I don't want to round that very much, so when I go to find my area of my base shape, I'm going to do 1/2, and I'm going to use as many decimal points as I can. Did you know the earlier that you start rounding things, the less accurate your final answer? So I'm just going to use a ton of decimals. 1/2. I got the apothem. That was a marathon. And now P is the perimeter of the base shape. We actually already figured that out, didn't we? Wasn't that the 15? Right. So now if you take 0.5 times that answer from before, that 2.06, dot, 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 times your 15, we got it. And I know that seems like it was a whole lot of work, but you've done all the work now. The rest of it's going to be super easy. Area, square, yeah. Again, I'm writing out all those decimal places because I don't want to screw up my final answers. I'm ready to find my final. You guys, it's going to be so easy now. I'm going to take 2 times that area of the base shape I just found and see how I'm going to double this number. So it's a good thing I haven't rounded it yet. Plus that perimeter of the base shape, which I figured out. And then the height. Remember, the height is the distance from base to base. And so that's a 3-inch height. So 2 of those base shape areas plus 15 times 3. I'm getting a total of 75.96. I'll finally round for the final answer. I'll round that to a 969. And that's a surface area squarea. That's how many square stickers it would take to cover the whole box. Well, let's fill her with water. It would take, area of the base shape, this many cubes of water to fill up that bottom layer. How many layers? Oh, I guess we have a 3-layer pool again. 3 layers of that 15 number. So I'm going to type in that whole number times 3. And now finally I'll round. Oh, I didn't do the approximately equal. Now I'm finally rounding to 46.453. And that's cubic inches of water.